Imagine standing on the red sands of Mars. The sky above you is no longer a dull orange, but a soft blue. The air is breathable. Liquid water flows in rivers. Plants grow in sealed valleys. And humanity has begun transforming an entire planet. This might sound like science fiction, but scientists around the world are asking the same stunning question. Can we really terraform Mars within the next 100 years? Welcome to NextGen Science. Today, we are diving deep into the real science, not fantasy, behind terraforming Mars. Why terraform Mars? Mars is the closest thing we have to a second home. It has water ice, a 24.6-hour day, seasons like Earth, and a rocky surface. But Mars is also deadly. No breathable air, extreme cold, no magnetic field, toxic dust, and a thin atmosphere. Terraforming means reshaping the planet so humans can live there long term. But is it physically possible? And if yes, how long will it take? Let's break it down. The first requirement: atmosphere. Mars' atmosphere is less than 1% as thick as Earth's. You cannot walk outside without a spacesuit. So the first step is obvious. 1. Thicken the atmosphere. Scientists propose several methods. A. Releasing CO from the Martian poles. The polar ice caps contain frozen CO. If we melt them using mirrors or nuclear energy, the CO would fill the atmosphere and create a greenhouse effect. But here's a reality check. According to NASA studies, there isn't enough CO on Mars to warm the planet significantly. Even if we vaporized all the CO, the atmosphere would still be too thin. B. Importing gas from other moons. Some scientists propose redirecting asteroids rich in ammonia, a strong greenhouse gas, and smashing them into Mars. This sounds dramatic, but it would release massive amounts of nitrogen, creating a thicker atmosphere. C. Artificial atmosphere factories. Future AI-controlled. Megamachines could continuously release gases to slowly build an atmosphere. This would be extremely slow, but realistic. Warming Mars. Mars is cold. Very cold. Average temperature: -63 degrees Celsius. To terraform Mars, we need to heat the entire planet. Method 1. Giant space mirrors. Massive satellites reflect sunlight onto the surface, raising temperature. Method 2. Greenhouse factories. Factories release greenhouse gases like fluorine-based compounds. These are powerful and long-lasting. Method 3. Nuclear reactors. Nuclear energy could melt ice caps and warm local regions. Is this enough to make Mars warm like Earth? Maybe, but it would take decades, not years. Water, the lifeblood of terraforming. Good news: Mars has water. A lot of it. Mostly frozen underground and in the poles. To terraform Mars. 1. Melt the ice. Nuclear energy, solar mirrors, or geothermal drilling could release liquid water. 2. Create small lakes first. Scientists propose starting with contained lakes inside protected craters. 3. Import water. If needed, ice-rich asteroids could be redirected to deliver additional water. Mars will not look like Earth anytime soon, but controlled water systems are realistic within 50 to 100 years. Breathing on Mars, plants and bioengineering. Even if we warm Mars, humanity still cannot breathe the air. The atmosphere will be mostly CO. So how do we make oxygen? 1. Genetically modified plants. Earth plants cannot survive on Mars, but genetically engineered plants could. Survive low temperatures. Live in low pressure. Use CO efficiently. Produce oxygen faster. These superplants could be grown in sealed domes first. 2. Oxygen factories. Machines like MOXIE, already tested on Mars, can convert CO into oxygen. Scaling this up could eventually change the air, but this process alone could take centuries. 3. Microbes. Some scientists propose introducing extremophile bacteria to slowly convert Mars. Soil and atmosphere. Radiation and magnetic field. Even if we create air and water, Mars still has a huge problem. No magnetic field. Solar radiation constantly hits the planet. Solutions. A. Artificial magnetic shield in space. NASA scientists propose a huge magnetic shield placed between Mars and the Sun. This would block solar wind and protect the atmosphere. B. Underground cities. Before full terraforming, Humans will live underground or in shielded habitats. See magnetic generators on Mars' surface. Gigantic machines could generate localized magnetic bubbles. This is advanced technology, but theoretically possible within 50 to 100 years. Timeline. Can we do it in 100 years? Terraforming a planet is not a project. It's a civilization-scale mission. But let's break the next 100 years. 0 to 20 years, 2025 to 2045. AI-powered robots build habitats. First Mars cities underground. Oxygen and greenhouse gas factories begin small-scale testing. Water extraction starts. Fusion and nuclear energy becomes main power source. 20 to 50 years, 2045 to 2075. Large-scale atmosphere thickening. Space mirrors deployed. Biodomes with genetically engineered plants. Artificial lakes created. First stages of magnetic shielding tested. 50 to 100 years, 2075 to 2125. If technology advances quickly, atmosphere becomes twice as thick. Temperature rises significantly. Open-air plant zones possible. Controlled outdoor areas without spacesuits, limited. Small regions become partially terraform-ready. Will Mars become Earth-like in 100 years? No. That would take centuries. But will Mars become human-friendly enough for limited outdoor activity, open water, and large-scale settlements? Yes, that is scientifically possible. The future of Mars. Mars will not become a second Earth in a century, but it will become a hybrid planet. Part natural, part artificial, part engineered by humanity. A world shaped by science, technology, and imagination. A world where your children or grandchildren could walk under a bluish sky. Not because Mars changed naturally, but because humans changed it. Terraforming Mars in 100 years is not about perfection. It's about possibility. And possibility is the most powerful force in science. If you enjoyed this deep dive into the future of Mars and planetary engineering, hit like, subscribe, and join us for more mind-bending science every week. This is NextGen Science, expanding your universe, one video at a time.